Well, hello once again. This is our last topic when it comes to this current topic set 1. Okay, again, we're talking basics of science, and so one of the basic things that we have to learn how to do is some problem solving skills. And so this video is about those problem solving skills. If you remember last video was on those quantities, measurements, and how we did unit conversions, so we did some dimensional analysis. And now we're moving into how do we solve problems that are other than, say, dimensional analysis or making measurements or things like that. Okay. I have kind of a general set of guidelines that I like to go by, and it's a way that I keep structure within problem solving techniques. I call it the picture guess method. Okay. Now the picture is the first thing. So as you go through and you read a problem, you really want to kind of read through it and see if you can get a visual representation of what's going on. We are kind of more visual creatures, I think, at times. We'd rather look at pictures than we would sit down and read. And so one of the things that we have to do is be able to transfer the words into images inside our head. It's going to help us understand how to solve the problem. So draw a picture first. Read through and identify the given information. Okay, this is kind of the thought process that goes through. I have to know what I have in order to figure out how to get what I want. Okay, and so I go through and I analyze the problem based on numbers that are associated in there, looking at the units, and then I try to go through and then find out what is it that I'm looking for. So the next thing is my unknown. After I have the unknown and I have my given information, I look at it and I say there's got to be a mathematical relationship that ties these things together. And so that's where I look for an equation. After I have the equation, then it's an easy thing. Okay, math is easy once you know the equation, because then it's a substitute thing. You just set it up by plugging the values in and then doing the manipulation of the math. Okay, so a lot of this is going to be fairly easy from about this point on. Okay, this is the hardest thing, right? I should say, not from this point. From this point on, it's easy. And from this point down, it's easy. Okay? It's really this thing right here that requires us to do the thinking. Okay? The hard part. So getting to that equation is kind of the hard part. But once we have it, it's not too bad. So let's take a look at an example problem. Okay? I have a block that has some dimensions. Let me erase this off there. Okay, I have a block that has some dimensions, and it has a mass, and they're looking for its density. Okay, so I'm reading through it, and I say, okay, it's a block. All right, so I'm going to draw a picture of a block. There's my block. Okay. So now I have that block. It has some dimensions, so I'm going to say it's 2.5 centimeters on one side, it must be 5 centimeters on another side, and it must be 3 centimeters on another side. All right. And it's found to have a mass, so I know that it has a mass that's equal to 75.0 grams. What I'm looking for now is the density. Okay, so density is kind of the key thing that I'm looking for. So I drew my picture. Okay, I figured out all my given information, and I am now going to find my unknown, which is density. Okay, so that's my unknown, and I usually label my unknown with a question mark. So I went ahead and labeled it. Now I need to find that equation, and again, that's the part that I said is going to be the hardest. So I have to think in terms of what does density mean, or how do I find density? Now, if you remember from the last video, density is a derived quantity. It's found by the relationship of mass and volume. Okay, so density is a property of matter. It has mass, it has volume. So my equation is going to be this: density equals the mass over the volume. Now, they didn't give me the volume, but they gave me the mass. So I have to, again, think about this in terms of what was given and try to find something that I can use. Now, they give me 3 numbers that are all lengths. I know they're lengths based on the units that were given to me. So they were all in centimeters. And if I take 3 dimensions and I multiply those 3 dimensions together, I get the volume. So I can get the volume by taking the length times the width times the height. So this is actually a problem that I had to come up with 2 equations in order to get to the answer. So that's kind of what you have to do sometimes in problem solving, is go through and find out all the different things that I can. So here we go. Now I've got my 2 equations, I just set it up and I can solve it. So my volume is going to be 2.5 times 3 times 5. Okay, so I'm going to grab my calculator. And go 2.5 times 3 times 5. And that gives me a value of 37.5. Now at this point I don't want to lose what the values, or I should say what the units were with this. This was in centimeters, centimeters, centimeters. So that gives me an answer in centimeters cubed. So I have a value in centimeters cubed. I'm now going to go back and try to find the density by taking the mass and dividing it by the volume. So 75.0 grams divided by the volume, 37.5 centimeters cubed. Okay, so I'm going to get my answer now when I take 75 divided by 37.5. And I get an answer of 2. Label would be grams per centimeters cubed. Oops. And I should, again, this is going back to our talk about significant figures. Remember that it's always better to keep more than it is to round off too early. And if I left it at 2, that would be a little bit too early. I'd probably want to put my answer in as 2.0, just to kind of keep me, maybe 2.00 even, to keep me within the range of what my measurements were. Of course, most of my measurements were at 2 sig figs, so I'm probably okay even at 2.0. But that's how I get my answer. Okay. So again, as you do problem solving, you're going to want to walk through, make sure that you draw a picture, make sure that you find your given, find your unknowns, pick out your equations, set it up and solve it. This is not easy stuff, okay? Problem solving is hard, but it's because you have to think in terms of a sequence of how I would process something, okay? How do you process this? There's no magic. I can't give you a formula for every situation. It's always going to be draw a picture, let's think about this, let's look at what's given to me, let's find the unknowns, and then let's try to solve it from there. Okay. The last thing I may want to talk a little bit about is scientific notation. And for those of you that don't know what scientific notation is, I did put a kind of a help document out there, but it is something that we've talked about in our classes a lot. Say, for instance, we're looking at an extremely large number like 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is in meters per second. So this is the speed of light. Okay, it travels. What is it? 300 million miles or million meters per second. Okay, so it's really fast. Now that is not a practical number to be typing into my calculator all the time. Typing 3 with 8 zeros is just going to be too much to put in there. So what I tend to do is I tend to use scientific notation, which says that I can then change this to something between 1 and 10. Okay, so you always stay between 1 and 10 when we're doing something in scientific notation. So I'm basically moving my decimal over until I get to a point, okay, after the first digit, and then I put a decimal there, okay, and then I carry however many zeros I would need to. In this case, I probably only need to be to 2 sig figs. And then I put a factor of 10, so it's times 10 to the 8th. And so how many places did I move? 1, 2, 3, 4, 5, 6, 7, 8. And that's all I had to do. Meters per second. This works for extremely small numbers as well. So if I had something that was an extremely small number, excuse me, 625, maybe this is grams. I could convert this into scientific notation by doing 6.25 times 10. Now I'm going the opposite way, so it's 1, 2, 3, 4, 5, 6, 7, negative 7, because I went in the opposite way. Negatives imply that it's a really small number. Positive exponents imply that it's a really big number, grams. Okay, and you should be able to go back and forth with that. Now when I use this on my calculator, okay, our calculators have a built-in key for this. And the built-in key is this one right here. It's the EE key. So when I type in a value, say I want to take these two numbers and I want to divide these two numbers. So I'm going to take the meters per second divided by grams. I don't know why, but I just figure I'll do that. So I'm going to take 3, and then I'm going to do second EE 8. Okay, so that says 3 times 10 to the 8th divided by, now I'm going to do 6.25 second E, okay, to the negative 7. So that's 6.25 times 10 to the negative second. And I'm just going to hit enter, and I get my answer. And my answer came out to be 4.8 times 10 to the 14th, okay? And so that's kind of how it comes out on my calculator. When we're doing this on the homework system through the University of Texas, you can just use an E and then put your exponent in. So in other words, I put 4.8 E14 as my answer, and that's how I could do scientific notation on there. Okay? So again, scientific notation, just another like language issue that we have to deal with when we're talking math and science. Okay? We will be taking a test now that we're through our first ones. This test is going to be kind of a mini test. It's not going to be a full-blown test because, again, most of this stuff should have been kind of review. So it'll be probably about five multiple choice questions with a couple of problems. Okay, it shouldn't take you too long, and we'll be able to move that into the next topic set. All right, so until tomorrow, we'll see you, and remember to study and picture guess.